lesson. Thank you so much for tuning in to this platform. I hope that at the end of the day you learned something in addition to what you learned the other time. Last lesson we learned about leaves, and then we had different forms of classifying leaves. Remember, we took through the dichotomous key very clearly, and also the next lesson I took you through different forms of leaf arrangement on the stem. So now we are going to continue about what called leaf complexity. It is not something new, it is an idea which you have already done before. So I want us to again build on what we already have, from what we know to the next thing. But again, encourage you, whereas this lesson is more practical, please you go and pick leaves from the surrounding, from the compound, wherever you are. Even when you are at the square, you know there are some leaves there, you can pick them, bring them to your sitting room. Study with me when you have something that you're touching on. Study with me when you're having something you're referring to, that at the end of the lesson you pick something practical, not just the theory that I'm going to take you through. Okay? So keep tuned in as I take you through leaf complexity. Now, we can divide leaves based on the what called the nature. How are they arranged in terms of are they divided or they are whole? Are there leaflets? Like is a leaf lamina? By the way, leaf lamina, remember we told you what leaf lamina is when we introduced you to these leaves. Leaf lamina is that surface of the leaf. Is the lamina divided or it is not divided? So if the lamina is divided, okay, before we go to that, I remember let's take a recap. Previously in your primary school you have been taught of types of leaves. Now tell me, which types of leaves do you know before we can push on, before we can pick on from there? Which type of leaves do you know as you? Okay? Yeah, so take me through of the types of leaves you know. One? Yes? Tell me the answer. I hope you remember something like simple. We have simple and hard leaves, isn't it? No, we have what called simple and compound leaves. Those are the types of leaves that we have. Now, what we base on to divide these leaves in terms of simple and compound? In primary, they told you to just say simple and compound leaves. But now here at this level, we are taking it deeper to say why is it simple? Why is the other one called compound leaves? So the simple leaf is a leaf whose lamina is not divided. Lamina, we are meaning the leaf surface is not divided into what we call leaflets. Okay? Whereas in a compound leaf, the lamina, what we call the leaf surface, is divided. Lamina is divided into what we call leaflets. So this is what we base on to say that this is a simple leaf, and then this is a compound leaf. So we base on this. I believe in primary we not have talked about this in detail. Now check in, tune in as I take you deeper through this simple and compound leaves. Remember, I told you to pick some leaves, and then we'll be studying them together as we go through this leaf complexity. Why are we studying it, by the way? It's not something that's just theoretical. When you move around the school compound, when you move around the home compounds, you meet different types of leaves. And then these leaves are used in classification. The structures of these leaves are applied in classifying. You can say these are leaves. For example, most of these are leaves which are compound. They have this kind of venation. You get that? They have network venation. You can even construct what called a dichotomous key, basing on the type of leaf, basing on the structures that are possessed by that leaf. So it is important that we take through the study of these simple and compound leaves. Right? So we have compound and then simple leaves. And then we have said, please take some notes, that simple leaves are leaves whose lamina is not divided into leaflets. Then compound leaf or compound leaves are leaves whose lamina is divided into what called leaflets. Are we together? So keep following me as I take you more and into details about simple and compound leaves. Good. Yeah, so a simple leaf, like I've already told you, is a leaf whose lamina is not divided. Now, here I have some examples with me. You watch as you study with me about these simple leaves. This side, I have these leaves, then this one belongs here. I'm going to put them here and we study them. I have this one which I've just put here, and then there is this one, there is this one, there is this one. Then I have this one, it also belongs here. I'm going to include it so that you can observe it vertically. Good. So we have types of leaves. This side we have one group, and then this side we have another group. I can call this group 1, and then this side group 2. When you look at these leaves, I want you to help me. I want you to study with me. Tell me which of these leaves are compound and which leaves are simple. And what are you basing on to tell me that these are compound leaves and then these are simple leaves? Yes? Yeah, as you follow the slides on the screen there, give me some reasons as to why you say this is for example compound, this is simple, and this is compound. Are we there? Right. Yeah. So here with me, this is what we call this group is simple, and then group 2 is compound leaves. Okay, so we have two types of leaves. You have simple leaves and then compound leaves. These are just examples. There are very many types of leaves in nature, but these ones are just a few examples that are picked from the surrounding to take us through today's study. So like I've told you, you should have a reason as to why you're calling these ones simple and compound. Now, I give you 1 minute as you are studying with me. Amongst those that you have picked in your compound, try to also use them. Group them into 2 groups. Group them into compound and leaf and simple before we can continue, so that you can follow with me. So that at the end of the day, you will see that the study is not by my own. I mean, it's not just me, but I also want to engage you that you group the leaves that you have picked into simple and then compound leaves. Then you can continue from there. Right? Now, we are talking about, let's start with what we call simple leaves. Now, having divided into 2 groups, simple and compound, remember we are talking about leaf complexity. And the reason why we are studying it, I told you it is important in classifying. Remember, we are under classification, diversity of living things. So it is very important that we take note of these types of leaves. Now, we are talking about simple leaves. Listen, we have said these simple leaves are leaves whose lamina is not divided into what we call leaflets. Now, someone is going to say, but you check, there are these ones. I see they are as if divided into what we call leaflets. You are very right, they seem to be. But now let's take a look. Here, let me pick this one alone. I first watch these 3. You can clearly see that this is a mango leaf. It is not divided. It is as simple as you can see. So it's a simple leaf because its leaf surface is not divided. Even this is a banana leaf, small as it is, of course. It is a banana leaf. Its lamina is also not divided. So it's a simple leaf. Now these 2, they seem to be technical. This is called purple leaf. Some of you have never seen it. Practically, this is called a purple leaf. Then we have what called a cassava leaf. These 2, they are also simple leaves. And it is the reason some of you may not be knowing, but the reason is the lamina is divided into what we call lobes. Lobes are not leaflets. Lobes are different from leaflets. Now, lobes are different how? That when this lamina is divided, it is not divided up to the margin I mean the midrib. The midrib is this main vein, okay? But you see these ones, they divide and then they stop somewhere here. So if it was to completely divide up to the midrib, then this would be a compound leaf. We could call this leaflets. And at the end of the day, we could say this is a compound leaf. But because these lobes are not fully divided, I mean the leaf lamina is not divided up to the midrib, okay? You see the midrib is this main vein. You can see the main vein is passing through this one here. You see the division ends somewhere here. It is in the middle, okay? So it is not fully, it's not completely divided up to what? Up to the midrib. So such a leaf we consider to be a simple leaf because the leaf surface is not completely divided. It is partially divided into what called lobes, okay? So the same happens to this leaf we are calling the cassava leaf. It is having leaf lobes whose lamina has not been divided up to the midrib. You can see it also stops somewhere. Practically, you try to carry it out at home and also examine it. Does the division go up to the midrib or not? Someone is asking now, what's the importance of me studying this? I've told you it is important in classification. You're going to go study biology beyond this level, and you're going to classify organisms. You're going to group them, and you need to know the structures, the observable characteristics of these organisms. So it's important to take you through this. Now, these are some of the technical leaves that that are under simple leaves. The purple leaf, okay, and then the cassava leaf. They are also simple leaves. But now, since they are not completely divided, but they are partially divided, we call them simple digitate. Simple digitate. Digitate means they are like digits, okay? Just as you can see my palm. This palm is not, it is not divided up to it. The fingers are divided at the end somewhere here. So they are digits. So these ones, these leaves, purple and cassava, they are simple digitated leaves. Now these ones are clearly simple. You can see that a mango leaf, banana leaf, and others, say avocado, those are simple leaves, right? So you take a study on those leaves which you have. Do you have a banana leaf with you? Do you have a purple leaf? Do you have a cassava leaf? Those are simple leaves. They ask you some of these, or they would say the cassava leaf is a simple leaf or it's a compound leaf. Definitely it's a simple leaf. And then the reason, you have to know why. Thank you for studying with me that about simple leaves. There are very many examples. I've just picked a few, and there are more. You can take a study tour around your home, a study tour around your community, study these leaves on your own, study them with your friends, in your groups. It is amazing. Right. Having taken a look at simple leaves, we can now move on to what we call compound leaves. I remember we grouped with you and we agreed very well that these are simple leaves and these are compound leaves. Now these are compound leaves, and because their lamina is divided into what we call leaflets, that's why they are what? They are called compound leaves, right? So we are going to take a deeper look into what we call compound leaves. Why are we emphasizing that these compound leaves? I've already told you their lamina is divided. Can we take an example? For example, this one. This is a banana. This is okay. This is a bean leaf. Now listen. It is a compound leaf. Someone will say, but this alone is a bean leaf. Leaflet actually. This is one. But now this is a leaf. This is one leaf. One leaf having what we call 3 leaflets. So these are leaflets. This is not a leaf, but these are leaflets. A leaf is divided into what we call leaflets. That's what makes it a compound leaf. So the whole of this is one leaf divided into how many leaflets? These are 3. Okay? So it is a compound leaf. Why? Because it's, it is fully divided. The midrib is this vein. Okay? You can see that it was one having one stalk like this. Then it has been divided. Each of these leaflet is having its own stalks attached on the main stalk. Okay? So this alone is called to be a leaf. Now these others are considered to be what? Leaflets. And the same happens to these ones. This is, for example, this one here. If you take a look, small as it is, you may not see it clearly, but this is also a compound leaf. We are going to see that as we continue discussing. Now there are types of compound leaves as we are going to continue exploring more. So let's take a deeper study together. Now the first type of leaf, of compound leaf we have, like I've already shared with you, is the one we call compound trifoliate. Compound trifoliate. Now the word foliate, it comes from the word foliage. Foliage is a word which means leaves. Okay, leaf, something which is vegetative. Foliage. Now when we say compound, trifoliate, it means, the word tri means what? I hope you already know. Di means 2, mono means 1, tri means 3. So the word trifoliate together means 3. You could say leaves, but then it is the leaflets. So a bean leaf, for example, I have shared with you, it is considered to be compound trifoliate because the leaf lamina is divided into what called 3 leaflets. It's already illustrated in the screen there, so I may not take you into details of it, but it is very important in classification. You are going to need it somewhere, and then you will use it. It is not only bean leaves that have this type of what? Of compound trifoliate type of leaves. We also have what called the what? The desmodium. Okay? Desmodium. Desmodium, we have very many types of desmodium. We have green leaf desmodium, silver leaf desmodium. We have cowpeas, those legumes, most of them, cowpeas, and others, those legumes. Most of them have this kind of leaf complexity, what we call the compound trifoliate, where the leaf lamina is divided into 3 leaflets. Very important. Now, take a look at those leaves that you have in your sitting room, in your compound where you're studying from. Do you have any that has this nature with these 3 leaflets? If not, you can take a look after this lesson. Try to find out about these leaves, how unique they are. You may not have you may not have seen mine here clearly, but after the lesson, try to search more about it. Okay? Thank you so much. Then we have another one, which we call the compound. The other is called compound digitate. Compound digitate. Now, remember, before we have come to compound, there is something we talked about, simple digitate. Now you can see we are talking about compound digitate. Compound digitate, now this is the opposite. Remember, simple, you say the lamina is not fully divided. Now here, the compound, the lamina is fully divided. We have leaflets, okay? And now this is an example where we have, for example, something like this. This is a leaf, leaflet, Then we have another one, like that. Then another one, something like that. Then another one, like that. About 5 of them, like that. So these ones, they are around 1, 2, 3, 4, 5 leaflets which are attached on one stalk. Okay. Now these ones are said to be compound digitate. Compound because the leaflets are fully divided, okay, up to the midrib. the main leaf, then they can be referred to as compound for that reason. Now digitate, because these are in form of digits. And an example, these leaves are very rare, but they are there in nature. An example is what we call the American spider herb. Okay? Another name for it is called the spider flower. Those who when you research in agriculture, you will find it is actually very edible. I don't know how it's called in Uganda, but in my culture we have another name. It is a very good, delicious. It makes a good sauce. You can actually even eat it. So it is a little bit sour, but its uniqueness is how it comes in this type of what? Of its leaf complexity. That its leaf is a compound digit. At times it's called a compound palmate. Palmate comes from the word palm. Okay? So it has five digits or 5, as you can see, our hand also has 5 fingers. So even this leaf is a compound palmate or compound digitate. So you can even try to research more after this. You can Google what called the American spider herb, or what we call the spider flower. Okay? Even the scientific name they bring for it is very important. So try to research about it. So it is also another form of leaf complexity when you're talking about leaf, compound leaves. It's a type of, it's an example of compound leaves. It's very good. We are not studying them just, for us to pass exams. It's not about passing exams, because, this is very unique. Like I've told you, very many cultures, you eat it, but it is fading out. You can research about it, and you can even get seeds and plant it to make money. This one, this American spider herb, okay? The spider flower. It has that kind of leaf structure. The compound digitate or the compound palmate. Thank you so much. I hope you have, I believe none of you has gotten this leaf amongst those that you have. But if you have got it, well and good. Now, it's not the only example. You can also research about others. Leaves with the compound digitate structure. Okay? Leaves with compound palmate, for example. Research about them. It is very interesting. Good. Then we have another one, which we call the compound palmate. The pronunciation of this may be different. Some others may say pinnate, others may say pinnate. It doesn't matter. But the most important thing, it is what called the compound palmate. Now, the word pinnate is the one very unique here. The word pin or peanut comes from the word what we call pin. Okay. So it is an extension in simple terms. A pin or pinna. You have also heard of this, of course. Biologically, pinna is this here. Pinna, what this one? Pinna is the outer drag. The what? This outer ear you see. So it is an extension on our body. Okay. Since it is an extension, it is called a pinna. Now, compound palmate, it means these leaves are divided further, just as you can see that our body has this one extended. We also have the compound palmate with one leaf, but the leaf is being divided into smaller leaflets, which are called pinnules. Okay, so we have this example of cassia. Cassia, I don't know how it's called in Uganda, but I think our language, they borrowed some English, and they said it's called matcassia. Matcassia is from my common language there. I don't know how it's called in Uganda, but this is not it. This is just an illustration. But then, how unique it is that the leaf is like having a leaf lamina like that, of which it is divided like that into leaflets of this nature, leaflets of that nature, like that. So this is compound pinnate, okay? So these are divided into what called the leaf lamina is all like this, and then it's divided into these ones which are called leaflets. They are opposite to one another. They all, I mean, this one is at the same point where this one is also leading, though they are on the opposite side. So this one is at the same point, or on the what? On this main, this is now the main vein, okay? The midrib now. So it is dividing at the same point, you can see. So these are leaflets. Now this one is an example of what called compound pinnate. There are very many examples in nature. Cassia is just an example. You can also get to study more about them. I hope amongst those leaves still which you have, luckily enough you could be having it. You can research more about them, and yeah, it is very interesting. It is very important in classification and other morphology. When you go beyond this level of biology, you will find it there. Alright? Then we have what we call compound bipinnate. Bipinnate. So you see this one was pinnate, now we are continuing bipinnate. Bipinnate is now dividing the pinnate again further into what we call bipinnate. So it is as unique as this. This one has almost dried, but we are going to use it for illustration. Now we are taking this as an example that this is a leaflet, okay? Now this is a leaflet, of which this leaflet has again been further divided into what we call again smaller leaflets. So this one seems to not give us a clear, but you can see it that let me break it from here. Right. So this is a leaflet alone. Now a leaflet has also been divided into further leaflets. You can see these ones. These ones are smaller leaflets, but this alone is a leaflet on this one. Okay. So a leaf lamina like this. Okay. Now this lamina has been divided into what called a leaflet like that. These are leaflets like this. But again, these leaflets have also branched to give us what we call smaller leaflets, something like that. Like that. So you can see smaller leaflets from a leaflet like that. Further divisions. It's like a feeder road. From the tarmac you have gone to Maram, then again Maram has branched into again another road, which is a feeder road. So these ones are further divisions like that. So these are smaller leaflets on again a leaflet. So that's why it's called bipinnate. Whereas this one is pinnate, this one is called compound bipinnate. Now an example of this one you can get from a tree. Some of you have never seen it, but acacia. Acacia, it is a tree with leaves. I mean, elephants usually eat the bark. The bark of this tree. They like it so much they eat. Of course, bark is on the stem. Elephants usually eat the bark of this tree. It has some thorns, but these elephants like it because it has a lot of nutrients. So when you go to the zoo, wherever you can also Google it, acacia. They'll bring for you the whole plant. You can now try to Google the leaves. It's very important. So acacia has this kind of what? Of leaf structure, what we call compound bipinnate. It's not the only one. We have what called jacaranda. Jacaranda also has this same type of compound bipinnate leaf structure. So it is important that you take a look and a study of these types of leaf structures. You'll be amazed of how they are. They can be used in different types of what? Different forms of classification. Like we did last time about the dichotomous key. So these ones can be used in make drawing, constructing the dichotomous key, which is used very so much in science and biology specifically. So it is good that you study them. I hope again you can find out. You may be lucky enough that amongst the leaves you have there, you have one with compound bipinate, but it is very rare. But they are available, so you can study them. Try to research with your friends. You can say this Saturday or next tomorrow, take a walk around with your colleagues. Study about these leaves. Pick some leaves which are having this kind of structure, compound bipinate. Pick those which are compound pinate, like that, and try to make it a dichotomous key. Try to discuss with your colleagues. It is very important. You will be amazed how it is useful. Right, so let's continue. So those are the types of leaves. We have talked about simple leaves, and then compound leaves, and the different forms of each. We have talked about simple, then simple dictate, then we have also talked about compound. Then under compound, I'm going to give you an activity. Which activity you're going to help me do? Good. So here with me, we are going through what? Let's do an activity. You're going to help me, not to help me, but carry it out on your own. Now this activity, this is how we're going to do it. We are going to have, basing on the leaves you have there, okay, in your sitting room where you are, or at home, the compound where you have picked the leaves. With the notes you have been taking, now let's do it in practically. We are going to have, you're going to pick 5 leaves. But now these leaves, I want you to pick them with some kind of order. Try to pick leaves which are not, looking the same. Try to pick different kind of leaves which you see that this one is looking different from the other, trying to look different from the other, and then try to study this. How? You're going to pick leaves and then you label them. For example, you make a column like this. You're going to get specimen A, then B, you're going to label them, then C, and then D, and so on. Okay? Now, I could have 5 or 4 or 6, regardless of the number. Let them not be more than 9 or 8, because they will be too much. Let the maximum be 8. Okay? You have those leaves there, and then the minimum, let the minimum be 4. We are going to do this practically. You carry out this activity. Now sort these leaves in this order. You are going to have a table in this form. You do what called structure characteristics here. Structure characteristics. In this column. Structure characteristics. Structure characteristics. Okay, this column. Then your specimens are this side. Now, what you're going to do is that you're going to follow under each of these specimens. You're going to be stating their leaves. Okay. For example, talk about the leaf. Is the leaf divided? Is the leaf divided into leaflets? Leaf divided into leaflets. Okay. Now you try to do this in your table. If this is leaf A, now assuming it's a mango leaf, hibiscus, mine have given you that table as you see it on the screen. That table may be having mango, hibiscus, it can be having acacia and other leaves. But now, depending on the ones you have, you label them. Okay. blackjack, and so on. Try to label them with letters so that you don't have the names in the table. They will be so complex to write. I mean, the table will be congested. Just put them with letters A, B, C, D, and so on. Now, we are taking a study together. So you write this table the way it is like that. Now, if the leaf is divided into leaflets, you tick. For example, maybe if A is divided into leaflets, tick. If this one is not, you do this. If it's divided, yes. Now I'm just giving an example. Now, if the leaf is divided into leaflets, give us the number. Number of leaflets. Okay? How many, if we have, for example, ticket A has leaflets, how many leaflets are there? Okay? Or lobes. Now, if there are 3, put 3. If this one doesn't have leaflets, then you cannot have the number of leaflets. If this one has leaflets, how many? If there are 4, put like that. So we are drawing a table of characteristics. Okay? Then you can continue giving us more about these characteristics. For example, you can talk about the type of Venetian. Or before you can talk about the type of Venetian, we have what called the lamina. Lamina is the lamina hairy or smooth. Maybe smooth or hairy. You touch it, you feel it. Is it having something like hairs or not? So you can write here if it is hairy, write hairy. If it's not hairy, you can just say smooth like that. Now this is something which is observable. You are drawing a table of characteristics based on the leaves you have in your compound, not the ones I'm having here. Okay? So you study with me this. Then you can also talk about these kinds of leaves in terms of what called the Venetian. You can study the leaves in terms of what called Venetian. Venetian, whether it is parallel or network. So you can, for example, say here it is parallel. Now, parallel Venetian. I remember in the last lesson I took you through what called parallel Venetian and network Venetian. When we were drawing the dichotomous key, the first lesson. Now, take a look. This one is parallel Venetian because the veins run parallel to one another. Okay? This is an example of the banana leaf, maize leaf, monocots. Most of them, they have what called parallel Venetian. Okay? Then the others, the most leguminous, dicots, they have what called network Venetian. So you try to take a look at the type of Venetian. You also write, if this is parallel, you write parallel Venetian, and if it's network, you write network Venetian, like that. For each of these specimens, draw that table. If you have a colleague who is also in the same class with you, or he is not in the same class, but willing to discuss with you, study with them. Draw that table of characteristics. Okay? Talk about the type of what? This is Venetian. I've talked about lamina. Talk about the margin. How is the leaf margin? The margin is the end, okay? Is it what we call entire? Entire, it means it is not divided margin. The margin, the outer side of the leaf is not divided. Just like you can see this one. This is entire margin because it's not what? Divided. Okay? Now this margin, this is a lobed margin. Okay? Because these are different. So you can see that it is having lobes. So this is not entire. So you write, if it is entire, you write entire. If it is having lobes, or lobed, you write a lobed, for example, for this specimen, and then entire. Now do not just write. Please, I've said, based on the examples of leaves that you have there in your compound, to write those, this table of characteristics. Are we together? Good. Then after writing the table of characteristics very well for each of these type of leaves, you try to go deeper. By the way, this is just an example of the kinds of what? Of characteristics. Me, I've extracted leaf divided into leaflets, number of leaflets, lamina is hairy, or smooth, Venetian, then the margin, then you can talk about the leaf sheath, okay? Leaf sheath, or the petiole. You can also talk about that. Right. Then you can give each of these characteristics in that table. Now, at the end of the day, after finishing that table of characteristics, I taught you what to call a flow chart. Now, take a look, go further, get this table of characteristics and use it to divide the leaves. To construct a flow chart for these leaves and then draw a dichotomous scheme based on the previous lessons that we studied. You can come up with a flow chart. You can come up with a table of characteristics. It is very, you can come up with a dichotomous scheme. It is very practical that you're going to become a scientist, you're going to become a biologist, you're going to understand this biology deeper and deeper. Where you don't understand, feedback is welcome through different platforms of WhatsApp where we interact, and also you can always interact via the social media platforms to find out how best you can understand this. This is very important. So at the end of the day, you will find that you have learned leaf complexity. Leaf complexity, it is important in classification. It is important not only to us but even plants. Each of these plants, they have their own unique characteristics, and this is one of them, leaf complexity. Okay? So before I leave this activity, try to carry it out on your own. Based on mine that I've given you, try to carry out your own. I've not given you my flow chart, I've not given you my dichotomous, but try to carry out your own. Try to find out your own and then come up with a dichotomous key and try to present your neighbor, try to present your fellow colleagues. In case you are in your own compound, in your own fence, you don't move out, the feedback is welcome through the different platforms that we can interact. So that is the end. We shall discuss more about leaf margins, the types of leaf margins, and then their morphology. We shall dig deeper into them, and then we find out how best we can do it. We can interact. But before I close, you put away your notebooks and try to remember what you have studied today. Put away your notebooks and try to list down this. You open a new page, for example, the type of leaves, we said there are two. So we are just trying to recap what we have studied, types of leaves. Remember we have talked of two. And then the others, you can also talk about the nature of what? Of each of them, okay? So further study we shall do the next time about the types of leaf margins. Thanks so much for tuning in, and keep there with me in the next lessons.